using Jupyter for things that aren't machine learning, please welcome Ludovico Bianchi.
Thank you, Chris. Thanks, everyone. Is the mic OK? OK. So if you heard about Jupyter notebooks before, chances are that this was somehow related with either the sciences or data science or some form of data analysis in general. And well, this makes sense because that's why Jupyter notebooks were invented and developed originally. But the usefulness of Jupyter notebooks does not end here. So I'm Ludovico, and I'm beginning from my career as a particle physicist until now working as a developer of scientific software at Berkeley Lab. I'm a huge Jupyter notebook fan. And today, I want to show you some of the tools that we are using to help making science easier to access, share, and reproduce. So the very same tools can also be used as a quick and efficient way to add interactivity to your code, even if your code has nothing to do with science. So Jupyter Notebook is just a very successful implementation of an older and more general concept, literate programming. If I had to describe it quickly, I would say it's either a document that you can run and execute, or a piece of code where the comments to the code are just as important as the code itself. And giving a proper introduction to Jupyter in this limited time would be very, very difficult, so I will try to do it in 3 words. Input, output, and prose. And all of these 3 aspects are essential for science or any analysis in general. We might think that the thing that we are most interested about is just what we produce, so the result. But how we produce this result, so the input to the analysis, and why we do this, so the prose that accompanies and explains the context and the motivation of why we did this analysis in the first place. All of these aspects need to be together in order for the scientific process to be documented correctly. And I want to point out how nicely this maps to the Jupyter interface. So at the most basic level, a Jupyter notebook is just a collection of cells. So cells can be of 2 types, either text cells, so we can edit here, and we can use either Markdown or LaTeX, and this will be rendered as rich text. And this gives us, as I said, the prose, so the context and why we're doing things. So in this case, we want to study values of the expression na 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 na. And then in the code cell, we have just a block of code, and that we can then run. So we then run the cell, and then the output is produced. So the fact that in a single document you have all these 3 aspects together, and you can edit, copy, share, produce your result, and reproduce your result without losing any of the 3, this is, in my opinion, ultimately what makes Jupyter Notebook so important for science. So today, as a way to showcase some of these tools that I'm talking about, I wanted to find some example which was simple enough to sort of be easy to explain quickly, but also interesting in its own right. And so I thought back at last year when I joined North Bay Python as my very first tech conference. And among many other things that were very different from a scientific conference, one kind of stuck out, and it was how fast and how much people were tweeting. I was super impressed. Okay, I'm already a slow typer on my laptop, and on my phone is even worse. And so I started to think, okay, but is there a way really to know who is the most prolific tweeter of North Bay Python? And I mean, the answer to this, the most sensible answer is, why would you even care about this? Well, since both scientists and coders, we are not really interested in a sensible answer. So, you just pull up your editor, or in this case, Jupyter Notebook, and you start coding. So first, maybe a disclaimer. This is my very first time not only giving a talk at a tech conference, but also doing any form of live coding here. And I think I violated the crucial rules of demos, which is don't use the internet and make it simple. So in this case, I'm using the internet. So, fingers crossed. So the basic idea is simple. We want to query the Twitter API to get a list of tweets, count, simply group them by username and count them, and then display the results. So we just access the Twitter API, and now we will know if it works or not. OK, seems so. And then we just search using the hashtag, and this will give us the latest 100 tweets. And then we simply use the counter object from the collections module to get a count of Twitter by username. And well, maybe the results are not very surprising at this point. So at this point, we can use this to calculate. So with the most common method, we calculate the top, let's say 20. OK, and then when you are tweeting faster than the actual account of the conference, it's we can also do something more. Let's say just display a simple scoreboard with the winners. One thing that is even at the level 0, so without introducing any new tools, already the fact that we can sort of pause the interaction, change parameters here, and then simply rerun it already is a form of interaction, right? Because you will not be able to do this with a code. You will have to rerun the whole thing from scratch. So I would like to call this level 0 of why Jupyter Notebooks can already give some interactivity. Yeah, the next topic is how to make the output richer. Because let's say we just take a random tweet. So I'm, if you think that this is biased, probably you should discuss with who wrote this function. So I try to be fair. And I mean, we see that the output, the wrapper of this object is very rich, but also a bit unwieldy. And if you want to know who's the user of this tweet, then it's a bit shorter, but still. So what we can use is from the IPython display module, there are several objects that just wraps any type of object and display a richer output in the notebook's output cell. So we'll just import them all. And so first, one that I want to show is the JSON that turns any JSON-able dictionary, so any dictionary with basic types, into a very nice widget. So for example, you start from here, and this is a dictionary, and it's large. And then you just do this, and automatically you have a widget, and you can filter by key. And then if you're interested in being the user, then we automatically do this. And it's very simple, but it's also very neat. I think it's very low effort, but it gives lots of results. So you can do the same with images, for example, either from a local path, or in this case a URL, and then we display the profile image of the author. And the Markdown object can be used to generate rich text, so the thing that goes into the text cells of the notebook, but programmatically. So you can sort of use it. Oops. Sorry. Should I plug in and out? Yeah. I'll try. Oh, yeah, OK. Thank you. That's it went wrong in a direction that I was not expecting, so at least I guess it's something. So anyway, with the Markdown, we give it a string, like a Markdown string, and this gives us the rendered output. And I think this is very nice. It's kind of low effort because probably most programmers are somewhat familiar with Markdown, and they might not be as proficient necessarily in HTML. So it's a nice way, in my opinion, to sort of have a very low, very simple but effective kind of templating engine in some way. If we want something more, then we can also render arbitrary HTML code. And yeah, so these are just the feed displayed in this way. And the notebook is able to support it completely. It's very long. OK. So what's next? So we can use this building blocks to create a rich representation of a custom object, not necessarily just basic types. So there are two main strategies. Either you register a custom formatter for object types. So let's say that you want to display wouldn't display this tweet in a nicer way. So you sort of build the string, and you take the text and you quote it using Markdown syntax. And then this is just a standalone function. And then you just take, in this way, you just take the formatter that would format this, and you associate this function with this object. And the way, I mean, the reason why I like this is because we didn't really have to do anything with the object itself. So this is a third-party library. And already in this way, it gives us something that's, we don't have to modify anything, and it already gives us a much richer output. The other strategy is that you can implement this single underscore wrapper methods in your custom objects. So let's say that we just moved to the tweet counting code to its own class. And so here we create this, again, wrapper markdown function. So this function is ignored by anything which is not Jupyter compatible. So it's also a good way of adding this functionality without necessarily making it incompatible with just normal code. And what you have here is just some rich output that it was put together very quickly and displays again the same results as before. So all of this is displayed automatically when the object is returned by the cell, so in the output cell. If you need to do this, for example, in a loop, then you can use the display function. And this just gives some of the tweets in this way. So now that we took care of the output, what about the input? Because in science, it's very important to give like a quicker way to edit the parameters of whatever code you want to give. Like, there's really a huge difference between being able to interact directly through a user interface and just editing some text file somewhere and just having to rerun it. And the way I want to show this is just imagining that instead of having instead of writing this code in the notebook, we just have a separate Python module that maybe we pip install. Someone was already interested in knowing who are the top tweeters in Northway Python, and so we just get this function which we don't know anything about, and we can just know what's the signature, what are the arguments in this way, and this is a default function of the Jupyter notebook. And in this case, we can just run it, right? We know the parameters, so if we want to run it, then it will display. What about if I want to have a different number here? So I just want to have the top 5. So we can do this, of course, but maybe there's a better way, and it turns out that there is. And so the IPyWidgets module contains many interesting things. And the thing I like the most probably it's how simple it is, as I say here, in just one line. So you use the interact function, and you just wrap the function that we get for the module. So the function that represents our, more or less what our code has to do. And this automatically gives you a rich widget interface. Again, none of this is particularly novel for if you're, of course, used to web development, but imagining that this is so easily accessible, even if you don't know anything about it, and it already, even at this stage, it makes a huge difference in usability. So here, what you have is that the input is displayed as the same, in the same way as the output, and then whenever you modify one of the sliders, for example, then the code is rerun. And then the output is updated in real time. So this is already valid. I mean, you have a dashboard in one line. We can see here, although, that there are some things that are kind of off, because, for example, we can display the top. We cannot really display. This goes to negative value, so we cannot really display the top -3 users. So, and the interesting thing at this point is that there is a way to for kind of suggest without having to write too much boilerplate code, to just get the slightly more specific widgets by passing different keyword arguments to interactive. So we can do so, for example, let's say that we do use a function exactly the same as before, but instead of displaying, so we just set here with a tuple that represents a range. So we just want this value to go from 1 to 20. We can specify that this timeout is in seconds, so it can be considered as a float. And in this case, the decoration, we can just give a list of possible values. And similar to many web frameworks, you have also the possibility of giving slightly more. These are just some options that are passed to the API, and these are just some more human readable with more context. And again, I want to stress that none of this is very ambitious, but it sort of already gives a huge difference in terms of how easy it is to do, especially for someone who doesn't have experience in web development, for example. And again, we can see here that the lists are transformed as we can expect into drop-down menus. And yeah, and the rest of the, in this case, it just goes until up to 1 or down to 1. And yeah, so apparently Sam is the winner for the moment, though. We can also get even further by using instantiating widget objects. So this is useful, for example, if you want to add a description, if you want to override the default value, which without the widget object is taken from the function definition and its arguments. Or you can have, custom intervals for floating point widget and so on. The interesting thing, in my opinion, here that I want to emphasize is how easy it is to sort of mix and match, right? So if you need something more specific with just a single widget, you're not forced to develop the whole thing. So it's nicely fits within the kind of iterative exploring workflows in a Jupyter notebook. So in this case, we could, for example, specify that the date, if you want to restrict it by day, this automatically display, or we select actually the kind of date display and so on. One useful thing that I might mention is how to turn off continuous update for slow functions, because we can see if, for example, we artificially increase the time between API calls and we start, decide to drag this, for example, it will not. Like it will all the time recalculate. So at every update, which is not necessarily, if we're just kind of thinking and just editing the widget at the same time, it's not what we want. So we can use either the interact manual function, and this will simply allow us to edit everything as before. But instead of doing it automatically, you can just have a button to press. At the same time, you can also do this on a per widget basis by setting the continuous update equals false. So you can have, maybe makes sense if you're editing some text to have it updated in real time and not for sliders and vice versa. And I will just mention here that there are also more, so you can actually, these widgets are very powerful. So you can assemble them similar to what we would do in a GUI framework. And so in particular, the interactive function just creates the widget, but returns it as an object instead of just displaying it. And the interactive output does not create the UI widget, so you have to provide your own, but then connects this existing widget with that function. So it's easy to sort of mix and match and create some more like wider structure using, again, this building blocks. So now that we have something, some nice, let's say, some nice app running on our computer, of course, the big question is how to make it run on someone else's computer. And this is also something which is very important for science. So the ability not only to access the research, but also to be able to rerun it is connected to the very important problem of reproducibility. And anything that creates friction in this process is very detrimental to the scientific process. First of all, because like reproducing the environment can be very confusing, and also because, yeah, basically it's extra effort that you have to do on top of the science, which is already pretty difficult. So one solution that was developed recently is a service called Binder. So Binder is super simple. So it takes any Git repo hosted, for example, on GitHub, and then turns it into a runnable environment for Jupyter notebooks. And the thing that the user have to do is just clicking one button. So that's it will automatically in the background like start the repository, build it, and create a container containing all of your code. And this can take a while. So what we have is just that we have a URL, so it is containing this in this button, and then this will create one instance of this running, which doesn't last very long, but that's not the purpose. So the purpose is just to facilitate just trying something. And of course, this is incredibly useful for science because, yeah, you simply eliminate the problem. So you don't have this problem anymore. But it's also useful simply even if you're not interested in the reproducibility aspect. It's, for example, if you have a your code on and you want users to try it, the fact that you can have something like this, it's very valuable because it's zero friction. And of course, I mean, users are likely to be at least familiar with how to build a package. But I don't know, I would compare it to the difference between something that costs $0 versus $1. So even if there is this just $1, it's psychologically it really makes a huge difference. And I had exactly this. So I was just trying some libraries, and at some point, I started thinking, oh, now I have to, open a new terminal window, create a new environment. I mean, nothing, it will take probably 2 minutes, but already the fact that they had a binder link, it took this decision away from me. And what's needed is just a way to describe your environment. So this is not Python specific, by the way. So as Jupyter Notebooks, this is supporting many programming languages. For Python, it's either requirements.txt or environment.yaml if you use conda. And curiously enough, what's not strictly needed is Jupyter Notebooks, because you can actually pass URL parameters in this way when you create the binder link. And so, for example, this should open the binder in directly in a terminal. So even if your code doesn't have anything to do with any Jupyter Notebooks, then you can still use it, and this will display simply a web terminal interface containing your code. Maybe we'll manage. Oh, that's it. And so this already contains everything that's in this repo. So lastly, I want to touch on one more aspect. So now we managed to get our code running everywhere. Let's say everyone can access it. But let's say that we want to make it not only accessible by everyone, but also make it more accessible. So what I'm talking about is trying to make science, like remove the barrier of entry of science. Of course, this is a very huge problem. It's an extremely important thing. But everyone benefits if science is more widely accepted and more widely understood. And we really want to eliminate everything which is limiting this. So one example that I like to make in this case is how in Jupyter Notebooks it's simply easy to make the code invisible, right? So this doesn't do anything in particular, but it's conceptually very powerful because on one hand, if you have something like this and doesn't contain code but still does the same thing, this allows users to engage with it in a different way that it just had this block of code there. At the same time, the fact that you can just peek under the hood, so to speak, it's very valuable, especially for scientists if at that point it's useful for them to concentrate on the task at hand, but also they want to have absolute control of what's going on and maybe even modify the code on the fly in case something requires a bug fix. And to this purpose, except for, again, this very nice built-in functionality of simply just hiding the code, and that's it, and you can just share the notebook in this way. I would say one step above that will be an app called Voila. So let's say that once we finished experimenting and we have this app more or less finished, we can just paste all the necessary code in one cell, and what we have here is just somehow a very easy way to deploy a web app, because we have the code here, we have the user interface again in the same page, and what Voila does is behind the scenes. Yes. So Voila will build will take your Jupyter notebook, run it so that all the outputs are rendered correctly, and just transform it into a standalone web app. And I will just describe it. In the end, what you have at the end is just something which doesn't tell you absolutely that it comes from Jupyter. And again, this is very useful because it's not only a way for, again, taking something that you started experimenting with and turning into like a piece of software that's, I mean, at least by the looks, like kind of production worthy. And at the same time, it's matching one more time, the explorative nature of Jupyter notebooks, in the sense that you start for something, you're just starting experimenting in a few cells, and then very organically you can expand this until you have something which just matches your functionality. And even now that I'm more familiar with, let's say, web development and so on, I really find myself reaching for these tools because it's simply so convenient to go through this transition. And well, I guess you have to believe me or just try it on your own because it seems that it's being a bit slow, but yeah. Just to wrap up what we discussed today, I just presented these 4 methods that you can use. These are all, in the end, very simple functionality, but the fact that it's so easy and so integrated with the Jupyter notebook, and it's somehow, I really want to stress how this is, like, again, everything that you do with, to make science in the being more open and accessible, there's really no difference. The end goal is the same. The end goal is to be more engaging for the users, allowing us to be lazier by using more efficient tools if we just want to have something quick and dirty. And I think these 4 tools are just a good example of this type of philosophy. Thank you.
All right, thank you very much, Ludo. So I have a few remarks on this talk.
Okay.
First, in response to the leaderboard, somebody called out on Twitter that it's an interesting coincidence that the program chair is at the top. I will say that at the time we reviewed the proposal, we were told the frame of the talk and it would be a demonstration of Jupyter and its capabilities. We were not told what the use case or the case study would be, so I had no idea that the tweets were coming. And to Benno, who is counting the number of tweet shamings of me, you can't shame somebody who feels no remorse. One more time for Ludo, please.
Yeah, that would be useful. Okay, so 2 talks left today. Our first